Hello everyone, I hope you are all doing well. I'm back with another video. In this video, I'm going to show you how to do ANCOVA or analysis of covariance in spss. Imagine that a researcher was interested in determining whether antibiotic A or antibiotic D was the best in reducing the scores of leprosy bacilli in 30 patients. We also have a control group named SF. So these patients are selected randomly for each treatment, and each patient are measured for leprosy bacilli. The researcher expected that any reduction in scores of leprosy bacilli elicited by the treatments, which would also depend on the participants' initial score of leprosy bacilli. So the researcher wanted to use pre-treatment score of leprosy bacilli as a covariate when comparing the post-treatment leprosy bacilli between the treatments and a control group. Therefore, the best option here would be running a one-way ANCOVA with post-treatment as the dependent variable, the control and two treatment groups as levels of the independent variable, and the pre-treatment leprosy bacilli as the covariate. But before running the test, we need to check whether the assumptions of ANCOVA are met or not. There are 8 assumptions that need to be checked. The first one is dependent variable and covariate variable should be measured on a continuous scale, which both of them here are met. And the second assumption is that the independent variable should consist of 2 or more categorical independent groups. As you can see, we have 3 groups here: antibiotic A, antibiotic D, and control group. And the third assumption is that you should have independence of observations, which means that there is no relationship between the observations in each group or between the groups themselves, which this assumption is met here. But the fourth assumption says that there should be no significant outliers. Outliers are simply data points within your data that do not follow the usual pattern. To find out whether our data have significant outliers or not, we need to go to Analyze, Descriptive Statistics, Explore, and put Post into Dependent box. And so from the plot, as you can see, we have no outliers. Otherwise, if we had outliers, we would have circles far from the last quartiles. So fortunately, we have no outliers here. And the fifth assumption would be that your residuals should be approximately normally distributed for each category of the independent variable. To check that, go to Analyze, Regression, Linear, and put Post into Dependent and Group into Independent box, and then click on Statistics, check the collinearity diagnostics, and then click on Plots. So put Z-pred into x-axis and Z-reside into y-axis, and don't forget to check the normal probability plot, and then OK. And as you can see, it is met because most of the data are around the line. So And also for checking the assumption number 6, which says that there needs to be homoscedasticity, we can check the plot below. And as you can see, there is no tight distribution to any side of the plot, and there are points equally distributed above and below 0. So this assumption is also met. And the assumption number 7 is checking the absence of multicollinearity using VIF values. So to check that, go to coefficients table. And so this value, as you can see, is below 10, which indicates that the assumption is met. But the last assumption, or the assumption number 8, is that the covariates should be linearly related to the dependent variable at each level of the independent variable. Or put it another way, there needs to be homogeneity of regression slopes, which means that there is no interaction between the covariate and the independent variable. So to check that, go to Graphs, Legacy Dialogues, Scatter/Dots, and then choose Simple Scatter. And so put posts into y-axis and pre into x-axis, and group into set markers by box. Then OK. So then double click on the graph and then click on Add Fit Line at Subgroups. So here we can see that there is no interaction between the covariate and the dependent variable. And for each level of independent variable, the regression of the dependent variable is linear and approximately the same. So there is no interaction here. Now we're good to go to do the ANCOVA test. So to do the test, we need to go to Analyze, General Linear Model, Univariate. And now put group into fixed factor box, pre into covariate, and post into dependent. So then click on EM means, then transfer group into display means for box, and then check the compare main effects, and then select Bonferroni confidence interval test and click continue. And then click on model, put group and pre into model box, and we need to build a customized model here for building group and pre interaction. So build group by pre and then add it to this box. And then click on options, check descriptive statistics and estimates of effect size and homogeneity tests, and then click on continue and then OK. So you can see the descriptive statistics table shown here that presents mean, standard deviation, and number of participants on the dependent variable for each level of independent variable. And move on to the next table that shows the results of Levene's test of equality of variances. P-value here is 0.703 and it is greater than 0.05. So it proves that the variance of dependent variable is equal across the groups. But finally, the main section of the result is presented in the tests of between subjects effects table. This table informs us whether the different treatments were statistically different, having adjusted for our covariate, or whether there was an overall statistically significant difference in post-treatment leprosy bacilli between different groups once their mean had been adjusted for pre-treatment leprosy bacilli. So here in the results table, the p-value for a group is 0.754, which is greater than 0.05. So there isn't a statistically significant difference between adjusted means. And now we don't need to check the pairwise comparison table as there were no significant results. And that's it. That was the way we run ANCOVA in SPSS, and I hope you found this video helpful. I'll see you in the next video, and best of luck for everyone.